A wealth of data is available to analyze. These are geophysical data from the Iceland's Reykjanes Peninsula, where we are expecting any moment an eruption. We see earthquakes concentrated along the what I have called Grindavik Rift Valley. You can see this earthquake numbers are increasing continuously. We have these numbers. This is Sunday, and still my colleagues in the Icelandic Meteorological Office are uploading this data there. We can see that the previous location of the eruptions in the past is now having a lot of steam over the past few weeks. It was almost like that always. And we are here also seeing the KayOne volcano, the crater. On the surface, probably we will not see much, but at the depth, the magma is being added, uplifting the land, shrinking in some other direction. Since the last eruption, the land uplift has increased. We had a steady rise. It never came back to the level it was before. Well, when you look at the latest data, for example, this is from Skipatsik Heron, you can see that we have almost risen 240, 250 millimeters, 24 centimeter higher. This is the amount of the magma pushing the whole 5, 6, 7 kilometers of the rocks above into the sky. This is a lot of force needed to do that. Interesting enough, in the east-west direction, we are seeing contraction of the ground, something around 40 millimeters, 4 centimeters. We are seeing that. This is kind of like a pinching of the ground. When we consider the position of the magma reservoir to the left side of it, it may be related to that, or it may be related to the pool of the Eurasian plate. Anyway, we are waiting for the sign of the gases from the top part of the magma reservoir. These are the gases dissolved in the magma and get released. When we see that, it means that the eruption is near. In the meantime, watch this video about the contraction and the stretching of the Rift Valley. Reykjanes Peninsula of the Iceland is a very interesting place. We have an extension of the earth crust in that area, which is part of the Mid-Atlantic ridge. And the stretching of it has created rift valleys. The most famous one at the moment is what I have called Grindavik Rift Valley. We can see in this area photographs from the Met Office of Iceland. You can see the rift valley and the fault lines and the range. This is the top of the fault line and the basin where the drop down of the faults and several faults that are there exist. Simplified version of that is this. What we think is this is the stretching of the lithosphere creates this uplift of the magma and eruption, and the Svartsengi volcanic system is formed here in this setting. We have usually eruptions now for the last 4, 5, 6 months. This is how it happens. It stretches the ground due to the uplift. We can map them by the GPS data, as you can see here, and the red line shows where the extension has happened and the uplift. And the uplift of this area creates a bulging of the ground, and the bulging that leads to the eruption, we can actually see that in the form of the eruption that happens in the Sunnuka craters. This is a Svartsengi GPS data we are seeing. Interestingly, when we have the uplift, after the eruption happens, we see a downfall, as if the ground falls down due to the magma flowing from the Svartsengi toward the Sunnuka crater to the east. In the Elfdorf, we have the opposite of that. What is interesting, east-west direction, actually, you can see it here. We have a contraction of the ground in the east-west direction, and the moment eruption happens, it starts to stretch back. So what we are seeing in the opposite side of it, in the Grindavik, is the exactly opposite of what happens in the Elfdorf. We see that up to the point of the eruption, the land is actually stretching until the point of the eruption. Then it starts after the eruption to contract. I've tried to show this in this diagram. Extension up to the point of the eruption. Then during the eruption and after that, we have contraction of the ground. This makes sense because the land is rising due to the magma accumulation, so it stretches and then contracts. In the adjacent regions to the opposite side of the fault lines, you will see the opposite of that. When there is extension, you see on that side compression, and the opposite again when it happens. This is an interesting observation. The land is breathing. You can see that the effect of it on the Elfdorp and the Swartsengi and the Grindavik area.